So today we are going to talk about bonding. When we talk about bonding, we're talking about how to take two different atoms or elements and turn them into compounds. The first type of bond is ionic bonds. Ionic bonding is the transferring of electrons. When an atom has a single valence electron, like you can see here with sodium, it will try to give it away because then its new outer layer will be full. So if we look at sodium here on the left, you can see that sodium only has one valence electron. It's easier for sodium to lose that one valence electron than gain 7 electrons in order to be full and complete the octet rule. So chlorine only needs 1 electron in order to have a full outer shell. So it's going to accept that electron from sodium in order to be full and happy and have a complete octet in its valence shell. This is going to happen between a metal and a non-metal, and it's going to be the transferring of electrons. If you look at this diagram here, you can see sodium giving its valence electron to fluorine. Because sodium is losing an electron, it becomes positive, and because fluorine is gaining an electron, it becomes negative. As a result, there will be one positive and one negative end of the compound. So if we look at our sodium and our chlorine example again, you can see sodium has 11 protons and 10 electrons because it's lost one, which is going to give it a +1 charge. If you look at chlorine, chlorine has 17 protons and 18 electrons because it accepted one from sodium, giving it a negative charge. Sodium by itself is a highly reactive metal that's going to explode in water. Chlorine is a highly toxic gas that can kill you if ingested. However, together, sodium chloride or salt can be sprinkled on your food and eaten. The next type of bond we're going to talk about are covalent bonds, and this is going to be when you share electrons. These are going to form molecules, and it's going to be the primary bonds in organic molecules. So if you look down here at these examples, here's chlorine. You can see that 2 chlorine atoms are going to equally share their valence electrons. They're not going to have any charges here. Same thing with our oxygen. Our oxygen is going to share its valence electrons in order to be full and happy. And then nitrogen is also going to share it. The difference between chlorine, oxygen, and nitrogen here is the number of bonds that it has to make in order to fill its valence shell. So for chlorine, we only need a single bond because it only needs 1 valence electron. If we look at oxygen, oxygen needs 2 more valence electrons, so it needs to make a double bond. And if you look at nitrogen, nitrogen needs 3 valence electrons, so it needs to make a triple bond. There are 2 different types of covalent bonds that you guys need to know. The first type is going to be a nonpolar covalent bond. This is going to be formed by an even sharing of electrons. So as you can see here with our 2 hydrogen atoms, they are equally sharing their electrons. So there's no charges here. If you look at polar covalent bonds are going to form because there is an uneven sharing of electrons. The way that you can think of this is like tug of war. One of the elements is going to attract the electron more strongly. So in our example here, we have water. The oxygen atom is going to pull those electrons tighter to its core, which is going to give it a slightly negative charge because electrons are negative. And the hydrogens, since those electrons are being pulled away from it, are going to become slightly positive. Now here we can see the difference between covalent and ionic bonds. Covalent bonds are going to be the sharing of electrons in that valence shell, and it's going to create a molecule. In ionic bonds, we are going to transfer electrons in order to have a full valence shell, and that's going to create a positive ion because it lost its electron, and a negative ion because it gained an electron. So these